So we'll take a look here today at quartiles and percentiles, what they are, how to calculate them, and how to use them. Our prerequisite skill is nice and easy. We've already covered calculating a median from a list of values. You folks have been doing that for years. You've been handling mean, median, and mode. Today we're only using median. If we have a data set like this, I'll encourage you, because it is not new for you in this course, I encourage you, start off, I want you to take this data here and calculate the median of it. Good, so we should end up with a median of 44 right here, where we can see we have arranged our values from least to greatest. We have canceled from the outside in, and we found the middle number is 44. Now again, the meaning of the median is that it splits our data set up into two halves, right, where we can see the left half here and the right half here. That's the whole point in the median. Now what we're going to do here is we're going to take that median and we're going to call it Q2, because it is the second quartile that we'll be working with. Now, and that might not mean anything to you just quite yet. That's quite all right. Now what we're going to do is we're going to take a look at all of the data, that is less than our median. And that is, we're working with 15, 24, and 39 in this case. And if we take a look at just that data, then we find the median of this smaller subset of data, then we would see right away very clearly 24 is right in the middle. That is the median of the lower half of our data, and we call that Q1. Following the same pattern with the upper half of our data, we have 58, 83, and 91. Nice and clearly, 83 is right smack in the middle right here. That is the median of the upper half of our data, and we call this Q3. Now the whole point here is that these three data points, 44, 24, and 83, they split up our data into quarters, right? Where we see we can have one quarter that is below this first Q1, we call it, a second quarter that is below Q2 but above Q1, a third quarter between Q2 and Q3, and a fourth quarter above Q3. Now, that's why we call them quartiles. Quartiles split our data up into four pieces. Quartiles are more useful when we're working with much greater data sets. They have more meaning. By much greater, I mean data sets that have far more data points. That being said, it would be very tedious to perform a calculation on, say, 100 numbers right here. But we're going to take a look over here. Now we have our Q1, Q2, Q3. There are three quartiles. There are always going to be three quartiles when we're calculating them. What we've calculated is Q1 is 24, Q2 is 44, and Q3 we're working with 83 right there. Now, let's take a look. Now that we have performed these calculations one time, I want you again, pause the video, find the median of this data, and if you're feeling comfortable, follow the same steps we just did to find Q1 and Q3 as well here. Good, now this time when we calculate our median, when we cancel out our values from the outside in, we end up with two values in the middle right here, 15 and 18. When we're calculating our Q2, the same way we've calculated our median in the past, what we're doing is we take the average of these two values, because we ended up with two values, but there can only be one median. So we take our, we'll call it Q2, which is 15 plus 18 divided by 2. We're working here with 16.5. That is our Q2 value. That's our median. Now this time, because we had to calculate our Q2, this Q2 that's separating our data set really falls right here. So when we're calculating our Q1 and Q3, we're going to use all the data that's beneath this for Q1, all the data that's above it for Q3, which means that because we had an even number of data points in total, that's why we ended up with two values for Q2. Because we had an even number of data points in total, we're going to use all of our values, all of our data points when we're calculating our Q1 and Q3. So for Q1, nice and easy here, I'm finding the median of the lower parts of our data. Q1 is 13. For Q3, I'm finding the median of the upper parts of our data. Right there, Q3 is 19. Nice work. Now again, the whole point of what we're doing here is that these data points 16.5, which falls right here. These data points split all of our data, split the total data up into quarters, right? That's 3 cuts of our data, 1 quarter, 2 quarters, 3 quarters, 4 quarters. That's the intention. That's how quartiles work. Now, those are quartiles. Quartiles split up our data into 4 quarters. Percentiles follow the same kind of logic, except they're not splitting it up into 4 quarters. They're splitting it up into 100%, 100 different percent pieces. So we're not going to perform that calculation ourselves, again, because it would be pretty darn tedious to go through a great big data set like that. But hopefully we can take the meaning behind a percentile to draw some conclusions. So Donna and Dave, they each take an IQ test. IQ tests themselves not very helpful when in terms of measuring IQ, but regardless, IQ tests do use percentiles to consider a rating. Now Donna scores in the 75th percentile. Dave scores in the 84th percentile. It's up to us to try and figure out exactly what these mean. Now, if we were working with our quartiles, remember our quartiles split up our data into 4 sections. Our percentiles would split up our data into 100 sections. So if Donna scores in the 75th percentile, what that means is Donna scored better than 75% of others who take this IQ test. I'll say that again. Donna scores higher than 75% of others who can take an IQ test or who took this IQ test. Dave scores higher than 84% of people who take an IQ test. This does not mean that Donna got 75% of the questions correct. It does not mean Dave got 84% of the questions correct. It means Donna scored stronger than 75% of others. Dave scored stronger than 84% of others. That's how we take meaning from percentiles. If you followed along, I'm hoping you're feeling more comfortable working with quartiles and percentiles. Nice work.